Good afternoon, everyone. I am James. Welcome to the ABCDE event about AI and Big Data Conference for Data Engineers. So, thank you for joining the workshop today, and I hope you do enjoy yesterday's speech by four big company, and I hope you learned something new. And today, before I start, if you can't hear my voice, please try to use the Google Chrome browser for best experience. All right. So you are allowed to use the chat box and Q&A function if you have any questions. All right. Thank you. And today we are honored to have a speaker from Smartcademy, Ms. Shumin, in the workshop. She is an AI engineering analyst, and she will share about introduction to big data. And welcome, Ms. Shumin. It's your time now.
Thank you, James. Okay, so let me just share my screen first. Good afternoon to everybody, and yeah, thank you so much for taking time on a Sunday to attend this workshop. So, okay, can I just check that all of you can see my screen now?
Yep, I can see.
Okay, great. So I'll just go straight into today's session then. So, so today we'll be doing a workshop on introduction to big data. So just a quick introduction about myself. I'm Shumin from Smartcademy. So Smartcademy is an online learning academy based in Singapore. You can go and check out our website, www.smartcademy.sg, and find out more about the different courses that we have to offer if you're interested. And a bit of introduction about myself. So I've been in the data industry for about 3 to 4 years now, and I started off as a data engineer doing big data in the telco industry before moving on to doing more data science in natural language processing, so focusing on text analytics. So if any of you have any questions on data engineering, big data, NLP, just feel free to reach out to me. Okay, so with that, let's start our workshop for today. So today we'll really be focusing on big data, and this is the agenda for today. So first we'll start off with what is big data, followed by why is it important, and then we'll talk about some of the common big data analytics tools that we have, that we use in the industry, followed by a hands-on session. So what I want to say is the hands-on session will be done using Python. So I have a poll in the poll, if y'all can see at the side. So if y'all can just go and answer the poll so I get an idea of how proficient you are in Python, so that I can kind of cater to that level of proficiency later on during the hands-on session. Okay, and any point of time, if any of you have any questions, feel free to just put it in the Q&A. Because right now I'm like in presentation mode, so I can't really see any of your Q&A, right? But later on, there'll be a Q&A session, and I'll try to answer all of your questions. Okay. So yeah, so let's start. So what is big data, right? So for those of you who may not have heard of the term big data before, let's go through it quickly. But before we talk about big data, we actually want to understand how big data came about. And to understand how big data came about, right, we have to understand first what was the evolution of technology that actually caused this huge spike in data in our current day and age. So first we start with the evolution of technology, and it has really provided us with an explosion of data. So if you think about just the evolution of the mobile phone, okay, think back to maybe like your younger days, or maybe some of you are too young. If you've seen a landline before, right? A landline is just a phone that you use to call your friends, you call your family, and typically it's just used to do a phone call, right? But with the evolution of technology, with the smartphone being created and all, you can do a lot more with your phone. It's not just calling your friend or your family or whoever. You can also do other things like send a message, send an image, send a video. You can even keep track of, for example, if you go for a run or if you go for a workout, you can keep track how long you took. You can even keep track of the amount of calories you've eaten in a meal, different things like that. You can even, if you have wearables, you can use that to detect your heart rate, your sleeping patterns, all these kind of things. So with the evolution of technology, you can see that there is a lot more data that has been generated and a lot more data that can be collected. Not just mobile phones. So if you think about IoT, Internet of Things, Internet of Things basically are devices which enable you to collect and transfer a huge amount of data. Okay, so if you think about the concept smart home, Smart homes, you have things like you have sensors within your house, okay, and you're able to, using your mobile app, right, you're actually able to change the temperature of your aircon, of your thermostat. You even probably have heard of things like Google Home, okay. So with Google Home, you can very simply say, hey Google, turn on the radio for me, or hey Google, I want to listen to Taylor Swift, things like that, okay. So all these, right, is using IoT, which is basically lots of sensors around your house. And if you want to extend this concept, right, not just smart home, you can extend it to an entire city. Okay, so you have things like smart city concepts. So, for example, Alibaba, what they did was in China, Hangzhou, right, they actually implemented a traffic monitoring system whereby they're actually able to monitor traffic and try to identify areas of high congestion and try to find out and try to come up with solutions based on the traffic patterns so that they're able to alleviate traffic congestion. And this system is using a lot of data. It's very data intensive. It's only through data that they're able to say, hey, maybe on certain days or certain hours, we should change the traffic light timing, for example, so that we reduce traffic congestion. So so this system that they implemented was so good that they actually, if I'm not wrong, they extended it to KL as well. So they implemented their city brain concept in KL to help alleviate the traffic congestion. Besides that, right, something maybe more common that you may see is for those of you who drive. When you go to a car park, they're able to tell you, oh, how many lots are there, which level has the most amount of lots. So all these are also using sensors, and all these data can be collected. Besides that, something a little bit more quirky would be things like a smart trash can. I don't know if some of you have actually seen this before. It's quite an interesting concept. Basically, you walk down the street and then you see a trash can there. So in the past, before they had all these IoT sensors, right, what happened was that the cleaner would go down and clear the trash based on a schedule that they have. Sometimes, if it's off-peak period, right, they go to the trash can and there's nothing to clear, so it's kind of like wasting their time going down and then there's like nothing much to do. But nowadays, with IoT sensors, right, they are able to monitor how full the trash can is before they actually go down to clean it. So it's really a lot more efficient. It's a lot more optimized. Okay, so all this is using IoT, and this also helps us generate a lot more data than before. Something closer to heart, something more common that people use would be social media. So if you go online, right, for example, your Facebook, Instagram, Twitter, you have lots of data that is being generated as well. So if you just look at the first row, right, you can see that in 2020, the total number of messages that were shared by WhatsApp users amounted to about 41 million per minute. Okay, so you can imagine that's like a crazy amount of data that is just being generated that we did not have before. Okay. And finally, the last example I want to talk about is the shift from brick and mortar stores to online shopping. So previously, right, before we had e-commerce, online shopping, we'll go down to the stores, to the brick and mortar stores, we go down to the retail, we'll buy clothes or buy food, right? So previously, the companies there wasn't really much data that they can collect. They probably just have like maybe the transaction data where they don't even have the customer data. They have like just purely transaction data, and then you can see that, at maybe 10 p.m. someone bought apples or something for whatever reason. Okay, but with the shift to online shopping, right? So from brick and mortar to brick and clicks, right? What happens is there is a lot more data that is generated and collected. So for example, things like how much the customer spent. This was already we were already able to collect this in brick and mortar stores, but you would also have profile information about the customer if they have a profile, right? You know, sometimes if you go online, you create a customer profile, you would have your details or input inside, so they can see who has been spending how much. Besides that, they also can see how long the customer spent on a website, on a certain page, before they actually decided to press the add to cart button and add the item to their cart. So they can see how long the customer was taking to decide to add this item to their cart. Besides that, they can also see things like what is in their shopping cart that they have not yet checked out. So maybe, you know, sometimes when you go online, you add different things to your cart, and then after that you just leave it there, and then you don't actually check out your cart, right? So they can also see these kind of things. And something more interesting is they can see, what were some items that I initially added to my cart that I then removed. Okay, so these are items that I maybe wanted, but I changed my mind. So there is really all this different information that can now be collected by all these different organizations. And if they're really able to harness the value in all these, harness all these data, right, and really analyze it properly, they'll be able to get a lot more value, a better understanding about their customer, and potentially improve the customer experience as compared to before. Okay, so you can see with all this, right, there is really a whole load of data that is being generated as compared to the past, where typically you will not even be able to collect all these kind of information. So the evolution of technology has generated really a lot more data than before. And also, a lot of this data that is being generated, right, is more and more unstructured. So what do I mean by unstructured, right? Unstructured typically is talking about structured data. Okay, structured data is more like tabular data. So like, your Excel sheet, your CSV sheet, your CSV file, all those are very structured data. You have like tables, you have columns, that on this column, for example, customer age is all supposed to be integer, customer name is supposed to be string. So these are structured data. Unstructured data would then refer to things like images, text messages, videos. For example, if you go and post a review on a certain restaurant that you went to, all these are all unstructured data. And just fun fact, about 80% of our data is actually unstructured in nature. Yeah, so there is a lot of unstructured data that is available out there. So you see, the evolution of data really has led to the rise of this thing called big data. So after saying all that, right, what is the definition of big data? So you're just knowing that, with the evolution of technology, we have a lot more data right now, right? So what exactly is the definition of big data? So we'll go back one step. Big data was actually coined by this guy called John Massey in 1987. And initially, when they were thinking about big data, right, they were actually thinking more of the data was so large, so complex, because you see there's really a whole lot of data that's being generated. And it's complex, meaning that it's unstructured, right? So it's not so tabular as before. You have images, you have videos, you have text, you have all these other forms of data as well, that it was not possible to use traditional processing methods to analyze all these data. And that's what they coined, that's what they called big data. Okay, so of course, with technology enhancements and all that, we slowly created more and more different solutions that were able to tackle all these big data. So after that, we refined the definition a bit. So typically, whenever we think of big data, right, we think of the 4 V's. Okay, so what are the 4 V's, you may be wondering? So the first one, right, is the volume. Volume is just referring to the scale of data. How much data do we have? How much data are we talking about? So if I can just bring your attention to the top left corner, you see that it was estimated that there'll be a total of 40 zettabytes of data created in 2020, which, so 40 zettabytes, what's that, right? It's actually about 43 trillion gigabytes, which is like really a huge amount of data as compared to before. So in about 2005, right? So from 40 zettabytes of data, right, it's about a 300 times increase from the normal amount of data that we'll be thinking about in 2005 to 2020. So that like, within that 15 years, right, you actually generated about 300 times the amount of data. So you can really see there's a whole lot of data that's being generated. So that's volume. The next thing that we have is something called variety. So variety is really talking about the different forms of data. So in the past, you just have tabular data, CSV data, right? But right now, we have other forms of data. We have text data. So you think about your tweets, your Facebook posts. You go on to do your reviews, right? In Yelp, maybe you want to review a restaurant, you want to review a hotel, all those kind of things. When you post a review, that text data is unstructured data. So you have unstructured data as well. And then you have videos, images. So all these different forms of data that causes a variety of data that you have. Okay. The next V is velocity. So the rate that the data is coming in. So right now, right, with your wearables, with your sensors, you're able to collect data by the minute, by even the second, right? So for example, your heart rate monitor, you're able to monitor your heart rate every minute or every second. What else do you have? For example, your sensors data, you're able to constantly monitor what is your temperature in the room, right? And then if the temperature increases or decreases, you'll be able to see that change, right? As compared to the before in the past, where, for example, if you're talking about, so for those of you who know census data, right? So that is the information about the entire country in the US, right? For example, they took about 10 years to collect the census data of US. So as compared to now, right, when you have like streaming data, you have data coming in at real time, where it's coming in really like every second, you have more and more data. Okay, so you can see really the rate that the data comes in is much faster now as compared to before. Okay, next we have something called veracity. So veracity is basically talking about the accuracy, the certainty of the data. How sure are you that this data is correct? So typically when we think about veracity, we'll be thinking if your data is human generated, for example, if the human is taking notes, or if the human is the one writing the review, or the human is the one conducting the survey and writing down all those values, right? There's going to be human error in the data, right? For example, you may have multiple surveyors going out to conduct interviews, okay? And then some person writes male as M-A-L-E, but another surveyor may write male as M and female as F. So all these different inconsistencies, you need to ensure it's all standardized in your final data set, okay? Because you want to make sure that in your data you have standards and it's all consistent. Besides that, for accuracy, right, it's also sometimes, when a machine breaks down and it's not able to send data and you start losing data, or sometimes when the machine is off calibrated, okay, and then you have inaccurate data. So you then need to calibrate back to account for that inaccuracy in the data, okay? So these are the big 4 V's that we typically think about whenever we think about big data: volume, variety, velocity, and veracity. Of course, if you go online and then you search big data, right, sometimes you see that there are 3 V's, sometimes you see that there are 4 V's, sometimes you see that there are 5 V's, right? I mean, generally, we are always talking about these main 4 V's of data: volume, variety, velocity, and veracity. Sometimes there may be a 5th V that is about value, basically the value that the data can bring about. But yeah, it's always about the same main idea, okay? So with that, we'll then move on to what is the importance of big data, right? So now that we know what big data is, right, and how you actually define big data, so why do you actually need all this big data? I mean, we can have all this big data, but why do you need to analyze it, right? What are the opportunities that it can bring, okay? So to give you some interesting use cases first, Coca-Cola, interestingly, right, they can actually do product creation based on user behavior. What does this mean? So in 2008, what Coca-Cola did was they came up with this vending machine, with this drink machine, right, where you can actually download an app on your phone, and based on that, you can decide how you want to customize your drink. Okay, so do you want Sprite in your drink? Do you want Coke in your drink? Do you want cherry? Do you want Fanta grape? What do you want in your drink? You can mix around with the different flavors. Okay, and then based on that, right, they actually collected all these data that people were ordering drinks from this automated vending machine. And based on that, they actually found out that, hey, a lot of people were actually ordering a mix of Coca-Cola and cherry. So that's quite an interesting flavor that a lot of people tried and they actually liked. So based on this data they collected, they actually launched a new product called Cherry Sprite as their latest flavor. So you can see this really, this new product creation, right, it was really based on data that they collected based on their users to try and find out what are some new things that their customers may potentially want to see. Okay. Next, something a bit funny as well, Facebook. So I'm sure most of you should be familiar with Facebook, right? So you can go and like a page, you can go and add friends and all that kind of thing. So Facebook did an interesting study. So what they did was they actually profiled their users, okay? So based on all their users, they studied their likes. So, when you create a profile on Facebook, you can see different things like your name, if you want to add, if you want to add all these onto your profile, right, you can add things like your name, your age, your education, your country, your residence, etc., right? So based on that, they actually took the users, their demographic information, as well as the pages that they liked. So something very straightforward they found was that Facebook fans of Barack Obama, so people who like Barack Obama, typically are going to be Democrats, which is quite straightforward, right? I mean, if you like Barack Obama and Democrats, it's a kind of like straightforward association. But something a little bit more different that they found was that, people who have a high IQ, high IQ here is defined as having a higher level education, okay, for example, going to university, they tend to like curly fries and thunderstorms for whatever reason. But there was a positive correlation between those two, meaning people with high education tend to like curly fries and thunderstorms. Okay, one thing that I want to highlight is positive correlation just means that you see a positive trend between the two, but it does not necessarily mean causation. Okay, so correlation and causation are two totally different things. High IQ doesn't mean a person having a high IQ doesn't cause a person to like curly fries. It just so happens that people with high IQ like curly fries. Okay, so that's a difference. And finally, they also tried to look into the people who liked Hello Kitty, and they actually found out that people who like Hello Kitty tend to be more open in nature, and as well sometimes be less emotionally stable. Okay, so that was what they found using their data and analyzing it. Okay, so if we were to go down to more concrete kind of more use cases that we have, right? What are some of the use cases that you can use with big data? E-commerce personalization would definitely be a very big use case. Okay, so e-commerce personalization basically, all your retail stores, right? They're able to collect whatever you buy. They're able to collect all these all these online e-commerce stores. Whenever you have a transaction, you buy something, right? They're actually able to track all these data, and based on all these data that they have, right, they can get a better understanding of what are the products that you like, what are the type of products that you like, and they can actually personalize products such that it's catered to exactly what you like. So really it's personalizing to your likes and dislikes. Besides personalization, right, you also have things such as recommender system. So what's recommender systems, right? So sometimes if you go to Amazon, okay, or um, if you go to Amazon or maybe even Lazada or Shopee, sometimes you may see like, customers who bought this also bought this. Or you may want to add this to your shopping cart, something like that. So they're actually recommending products to you to buy. And this is also recommender systems are typically based on historical data as well, whereby they actually compare you to their other customers and they see how similar their customers are. How similar am I to another customer? So let's say if another customer are very similar in buying habits, right? And there's a product that that customer bought that I didn't buy, they would actually recommend that product to me. So hey, you may actually be interested to buy this product. So recommender systems are also a very big use case for that you can build using big data. Okay. Another very common use case that we like to look at whenever we have a lot of data, big data, is insurance fraud. Okay, so fraudulent transactions. So typically, right, in the insurance industry, like whenever you buy an insurance product, right, and then after that you go and claim, you go and log a claim. So you want to claim, for example, if you fell sick and you want to claim your medical bills, right? So you log a claim. And in the insurance industry, typically you would expect when there is a high turnaround, when they are able to pay out your insurance as fast as possible, right? That would typically be a good customer experience, right? It'll be like you feel happy that okay, I got my money fast. I didn't have to like go through a lot of forms, a lot of red tape to actually show the company that I fell sick and blah 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 and prove all those. So when they're able to pay out fast, it's actually a very good customer experience. And typically your companies would want to do that so that when you have a better customer experience, the customer will come back, they'll recommend your product to other people, and you will have more customers coming to you to buy your product, ideally, right? But on the other side of the coin, you have things such as insurance fraud. So some people may actually not be sick, but they actually just wanted to claim for whatever reasons. And then in order to prevent too much loss in profits, right, the company needs to hammer down on all these fraudulent cases. So they need to strike a balance between providing the customer with a good experience as well as fighting fraudulent cases, right? So they can actually make use of big data to try and analyze historical events where they know that when a customer when a customer actually claimed the product and it was actually fraudulent in nature, they can try and analyze all those data and predict potentially for the new customers, right, which of them may potentially be fraudulent as well. So once they have this kind of algorithm in place, right, they'll be able to kind of fast track those that are potentially have a low probability of being fraudulent, and they'll be able to immediately pay out those insurance claims. And as a customer, you feel very happy, right, because it was like a very fast and easy experience for you. So that's how big data can also be used to help fight insurance fraud. Okay. Next, we have something called log analytics. So, what is log analytics, right? Log analytics basically is looking at all your log data, LOG. So, log data typically is things like when you sign in, it will say that, oh, user signed in, user signed out, user keyed in wrong password, that kind of thing. Or even like, for example, when you add different items to your shopping cart, it will say that, oh, this user added item A, item B, item C to shopping cart. But then later, a few hours later, maybe you decided, actually, I don't really want to buy this. And then you remove it from your shopping cart. So all these are log data that customers, that companies can also collect. But you see, right, when log data comes in, it's like a huge amount of data, and sometimes like it can just be customer key in wrong password, and that kind of thing may not necessarily be the most important to them if they're trying to identify who they should target a new marketing campaign to try and push for maybe um, their latest season of products, for example. So they can also make use of log analytics to dig deep into their data and get a better understanding of their customers, if they're looking at customer log data. If not, right, log data can also be your machines, what was the temperature of your machine, what was the frequency of your machine, etc. So all those kind of other things are also stored as log data, and they can also try and use that to do predictive maintenance, to try and predict potentially when a computer may break down, when a lift may break down, etc., and then provide the necessary maintenance for those components to prevent it from breaking down. Okay, and all these can be done with the help of big data. Okay, so you can see that there's really like a lot of opportunities, um, a lot of things that big data can bring about if you're able to harness it properly. Okay, but what are some problems of big data that we're unable to cope with, right? So typically when you think about big data, right, if you recall, we say that big data, the first V was that it's very voluminous, right? There's a high volume of data, right? 40 zettabytes of data in 2020. That's a huge amount of data. If you want to store it, right, you must make sure that you find the best, most efficient way to store it, because the amount of data is huge. So if you are just using servers and if you use huge servers, it may not necessarily be the most cost effective, and it can be quite expensive. Okay, and typically, right, you also need to think some considerations that you have, right, is, for example, how long do you want to store all these data for? Are you going to store this data for 10 years? Can you imagine if you store like 40 zettabytes and then you times 10 or even exponential increase of data, and then you want to store it for 10 years? That's going to be a crazy amount of data that you have to store. So you need to identify how you're actually going to store this data. And let's say, right, you store all this data in a single server. What happens if one day there's a spike in your data? So for example, if you think about 66 sales, 77 sales, right, you have all those sales, and then you expect a lot of people to be buying things during the 66 or 77 day, right? And you have a sudden spike in transactions. Would your server break down? Okay, and if your server breaks down, then how? What happens to all the data? Is it going to be lost? Okay, so what happens? So whenever you're dealing with big data, storage is something that is very important. You need to be able to store it properly, such that if the server breaks down, maybe you have a backup somewhere. Okay, so we'll be addressing all these later. The next thing is that the data is coming in at potentially real time, right? Every time someone makes a purchase, every time someone makes a transaction, this is coming into your database and you're storing it as a transaction, right? So can you imagine how for example, if you think about China, right, how many people there are in China, and if every minute someone is buying something, right, can you imagine how many transactions that are going through, and how many transactions they need to store in their database, right? And let's say, right, you want to analyze the data as it comes in. So you need to ensure that the speed of processing your data is compatible to the speed that the data is coming in. Okay, because if the data is coming in at, for example, 1,000 transactions per minute, but you're only able to analyze 500 transactions a day, for example, then your processing speed and your speed that the data is coming in is really like misaligned, and it's not really doing justice to the amount of data that you have. So ideally, you will also want a solution that is able to analyze that allows you to process your data as it comes in. If it's real time, then you may want to look into a solution that allows real time analysis. Okay. So there's something here that I want to talk about, which is a batch approach, right? So here, batch approach, BATCH, versus real-time analysis. So a batch approach, right, basically is analyzing your data in a batch. So maybe you want to do your data analysis maybe like once a week. So on a weekly basis, maybe every Friday, you take all your data and then you analyze it and then you have a result. Okay, that is batch approach. Another approach is more real time. Real time means as the data comes in, you're analyzing it and coming up with insights. Okay, of course, a real time analysis data solution is going to be a lot more complex, a lot more expensive, but the insights that you get really are a lot more impactful because you're really seeing like real time what is happening. But of course, you will need to, everything at the end of the day, you will need to identify your use case. For example, if having real-time analysis doesn't really benefit you, then you can go and consider the batch approach. Okay, so that is for data processing. Finally, one of the other issues that we typically have with big data, right? So if you recall, big data, the other V we mentioned was variety, right? There is a huge variety of data. So the data is very complex. You can have things like images, videos. For example, if people are lodging a complaint, right? Okay, so they're lodging a complaint on maybe like an online platform and they're saying, oh, the restaurant that I went to today was horrible. The food wasn't good. It was really a bad experience. And then they take a photo of the food and they put it in their review and they submit it. So you see, if you want to store this data, right, you have text data and you have image data, and of course there's a whole other there's a lot more log data inside. You can see the user, what time they log this complaint. If you have user profile, you can also get that kind of information. But you see, there is a lot more different formats in data, right? You have a lot more different structures in your data. Okay, and besides just the structure of your data, right? Data can also come from multiple sources, right? You may not necessarily just be taking data from a single source. You may not just be taking data from this review website. You may also have reviews on Instagram. You may also have reviews that are being sent into you email, or you may also have people calling into your restaurant and saying, hey, oh, I was really happy with the service today, blah blah blah, that kind of thing. Okay, so data can really come in many different sources and many different formats. So you need to come up, so whenever we're looking at big data, right, we need to have a solution that is able to cater for all these different types of formats. We're able to store all these data inside our system properly. Okay. So how do we actually do that, right? How do we actually solve all those big data problems that we mentioned, right? So we actually have some tools here, some big data lifecycle and big data tools that we actually use in the industry, which we'll be talking about. So the first tool that we'll be talking about is Hadoop. So I don't know if some of you have heard of Hadoop before. Hadoop is basically a big data storage tool, and it's very common. Whenever you think of big data, typically you'll be thinking of Hadoop. What I want to say, for Hadoop, right, just some like interesting fact is that you see this cute little elephant, yellow elephant here, right? So how the name Hadoop actually came about was that one of the co-founders of this solution, right, his son actually had a cute little pet stuffed elephant, and it was called Hadoop. So because of that, he decided to call his this project Hadoop as well, and that's why you see there's like a cute little elephant there. Okay. So what is Hadoop? Right, so Hadoop basically is a framework that you use to store and process all these large amounts of data. So it really helps you to store big data basically, okay? So Hadoop, right, is a distributed file system. So you can see this thing called HDFS here. It's called a Hadoop distributed file system. And typically when you're thinking about Hadoop, right, you're thinking about a whole cluster of nodes. Right, rather than a single server where you used to store all your data, Hadoop is a cluster. So meaning, right, in your cluster, you can have multiple servers, could be multiple servers, but it's typically multiple nodes in your cluster, and they are all talking to one another and storing your data. Okay. So Hadoop and its ecosystem, right? So Hadoop basically is a Hadoop distributed file system, HDFS here, which basically you store your files in a Hadoop native format, and it parallelizes the data across the cluster. So typically this means, typically Hadoop has a replication factor, something called a replication factor, which is basically talking about how many times your data is duplicated inside this HDFS, inside this Hadoop distributed file system. And typically you're looking at a replication factor of 3. So what this means, right, is that within your cluster, your data is stored on 3 different nodes. Okay, so if any point of time one of the node goes down, one of the node is breaks down, has a power failure, or whatever, right? Your data is still stored on 2 other nodes. It's kind of like a backup, right? So if you just talk about a standalone server, right? If the server breaks down, all your data is kind of lost. But if you have a cluster, one server goes down, one node goes down, you still have 2 more nodes that are available that you can get your data from. Okay, so that is your Hadoop system. And this concept basically is called high availability, HA, if you're interested. Okay, and also if you recall, the other problem that we talked about just now for big data, right, was that you want to make sure that your big data solution is able to process the data as it comes in potentially, right? Because I mean, if you have so much data coming in so fast, and if you're only able to process it at a very slow rate, it kind of doesn't really does justice to the amount of data that you're storing. Okay, so Hadoop has this algorithm called MapReduce here. I'm sorry. Hadoop has this thing called MapReduce that you can actually use to process your data in parallel. So MapReduce is much faster than just processing your data in linear form. So MapReduce, we won't really be talking about MapReduce today. If you're interested, you can go and read up more. But MapReduce basically, it like kind of splits up your data and processes each part of the data simultaneously in parallel. Okay, so it's much faster. So that's MapReduce. And of course, within the Hadoop ecosystem, right, sometimes you may hear things as, Yarn, Hive, and Mahout. So I'll just quickly talk about this. Yarn is basically short form for yet another resource negotiator, YARN, and basically it helps to schedule any of these any script that you want to run, any algorithm that you have that you want to apply to your data, you can actually use Yarn, a scheduler, to help you coordinate your applications. The next thing you have is Hive. Hive is basically a SQL-like interface. So for those of you who don't know SQL, Standard Query Language, is basically a type of scripting language that you can use to interact with your data. So it's all your select star from table queries. Okay, it's basically to help you interact with your data, which is stored in the HDFS file system. Okay, and finally, the last common thing that people typically talk about in the Hadoop ecosystem is basically machine learning, right? Whenever there's so much data, it's definitely a great opportunity for machine learning. And so Hadoop typically partners with Mahout, pairs with Mahout in order to do the machine learning. Okay, so that is Hadoop. Another solution that we typically have in the big data world, right, is something called Apache Spark. Okay, so one thing to note, Hadoop and Spark are not like, Hadoop and Spark typically are used together in a big data solution. So people typically use Hadoop to store all their data because it's a distributed file system, right? And then they use Spark to process the data. So if you recall here, right, we talked about MapReduce. MapReduce was the algorithm to process the data, right? But Spark is actually a much faster processing engine for your big data. So Spark kind of replaces MapReduce here, okay? And it can work together with Hadoop, but they are not like the same company, right? Like, like Microsoft Word, Microsoft PowerPoint is under Microsoft, right? Microsoft Office. But Hadoop and Spark, right? Even though a lot of people use it together, they are not like the same product. They are like 2 different products, but people like to use them together for big data. Okay. So I've talked so much about that, right? What is Spark? You may be wondering. So Spark, right, basically, as I mentioned, is a processing, basically helps you process your data, and it kind of fights with Hadoop's MapReduce. Okay, and the difference, right, is that Hadoop's MapReduce works in disk, whereas Spark works in memory. Yeah. Hello.
Maybe the presentation
Sorry.
slide is you need to re-upload and see.
Hello.
Yes.
Oh yeah, you can see me, right? Sorry, I think my
Yeah.
connection went off. Okay, can you still see my screen?
I cannot.
Oh, cannot see my screen. Okay, sorry. Hold on. Let me share my screen again.
So everyone, if you have any questions until now, please feel free to ask. And I see a few questions actually.
Oh, okay. Let me answer a few questions first then.
Yeah.
Since there are some questions before I carry on.
Yeah. We can show on stage. Okay,
Oh,
so
okay, great.
Ms. Shumin, can we use big data in education or academy? Can you mention use cases of big data in online classes and online education? Thank you. From Fernando Lamino, Philippines.
Okay. So yeah, great question, Fernando. Right? I hope I'm
Yeah.
pronouncing it correctly. Great question. Yes, definitely you can use big data in education or academy. So big data, right? That's actually going to be addressed in one of my slides later, where there's like a misconception that people say that hey, big data is only for like the big companies, is it? Like only big companies can use big data, but that is not necessarily true. So anywhere, right, as long as you have data. So if you're thinking about education, I don't know, maybe if you have all your different data about your students, or if you have, for example, sometimes if you have your attendance data, or if you have how long the student attended a lecture or how long the student any kind of data, right, you will definitely be able to do big data and do some sort of analysis to help you better figure out maybe what works best for students in the classroom. Maybe you can try analyze like if there is some sort of correlation between maybe grades and how the student has been in the classroom, that kind of thing. So as long as you have data, right, you can definitely do some sort of big data analysis. And typically, if you recall, right, big data, we're talking about the 4 V's, right? Volume, variety, velocity, veracity, right? So as long as your data kind of like checks all these 4 boxes, right? It will be kind of classified as big data, and you can definitely use the big data solutions. You can definitely use the big data solutions for your data. Yeah. So if you have any specific use case or data that you would like to talk about, you can reach out to me separately, or you can put it in the next Q&A, and I can address it. Yeah.
Thank you, Ms. Shumin. And the following question is from the same person.
Okay.
He asked, can we have a copy of presentations, PPT, or speaker? Can we request?
Yeah, sure. Oh, yeah, actually, okay, so because in a short while, we'll actually be doing the hands-on session. So let me just share the link first. Okay. Link.
I think so many participants are requesting this, but thanks for Fernando asking.
Okay. If I paste it in the Q&A, can all of them see? Or should I paste it?
All right, I will close the Q&A first.
Oh, okay. I'll paste it in the Q&A session. Okay.
Okay, let me see. I can see it, but
Is it there? Oh.
do participants can see it? Can maybe someone answer?
Oh, should I paste it in the chat?
Okay, so everybody can see. Thank you for the answer.
Oh, okay, great.
All right. Do you want to continue to the Q&A section or continue to sharing your?
Okay, yeah, we're running a. Okay, let me finish the slides first. Then I'll move on to. Okay, so I've pasted the link, right? So you all should be able to see the slides as well as the Jupyter notebook, which we'll be using for the hands-on session. So our plan is I'll finish the slides first, then I'll take a Q&A, and then we'll go on to hands-on.
All right.
Thanks, James.
All right.
Okay, let me share my screen again. Share. Okay.
I can see it.
Okay, great. So I think I stopped here.
Here, yes.
Okay, yeah, I'll just carry it. It's just like a bit more. We're almost there. Okay, just hang in there with me. Okay, so yeah, let me just quickly go through Apache Spark. Okay, so what we were talking about just now, Apache Spark, right, basically kind of like replaces MapReduce here. Okay, so basically Apache Spark is like your processing algorithm that you will use to process your data, and typically it will be used hand in hand with Hadoop. Okay, so Apache Spark, so as I mentioned, it processes data in parallel across the cluster, and the biggest difference, right, between Spark and Hadoop's MapReduce, right, is that MapReduce does all the processing in disk, whereas Spark does it in memory. So because of that, right, it's actually much faster in processing compared to Hadoop's MapReduce. And so if you go online and you go and search Spark, right, you can see that a lot of people say that, Spark typically will work 100 times up to disclaimer, up to 100 times faster than MapReduce in Hadoop. So that's why people typically in a big data solution like to use Spark to process the data rather than using Hadoop's MapReduce algorithm. Okay. So Spark, right? What are some components of Spark? So Spark typically will have a Spark core, a core engine that basically does all this processing. You can think of it as like the heart of Spark. Then we also have something called Spark SQL. So similar to, if you recall, Hadoop, they have Hive, right, which basically lets you run SQL commands on your data to get like quick information about your data. So same thing, Spark also has Spark SQL where you can run all your SQL queries. Okay. Then Spark also has something called Spark streaming. So if you recall, one of the other problems that we typically face with big data was that when your data comes in, your processing speed is not as fast as how fast your data is coming in, right? So you want to be able to process your data, like do some sort of streaming analytics. So Spark has something called Spark streaming, whereby it actually allows you to transform your data as it comes in. Okay, so as your data comes in, it actually transforms your data, and then you can do all your analysis. Okay. And again, like, you know how whenever you think about big data, you'll be like, oh, I want to do machine learning. I want to build some models on my data to really try and squeeze the value out of my data, right? So Spark also has something called MLlib, which you use for machine learning. Okay. And one more special thing that Spark has compared to Hadoop is something called GraphX. So GraphX, right, is typically for graph problems and for graph kind of data. So when I'm talking about graph, right, I'm not talking about those like bar chart, line chart, this kind of graphs, but it's more like if you know a network. So typically, if you think about a social network, right, social network, you have things like nodes and edges. Okay, what do I mean by nodes and edges, right? It's things like, for example, you can see how maybe I'm friends with someone else. You can see that we have this network, and maybe I'm friends with 10 other people. So you can see like, this is me, Shumin, and then I have like 10 other people connected to me. So that kind of like structure is called a graph structure. And the good thing about Spark is it actually has GraphX that helps you visualize that structure. So this is kind of very niche and is very good for graph kind of data. Yeah. Okay, so that is Spark. And then Spark and its ecosystem. So Spark and its data, right? So typically for Spark, right, whenever you load your data into Spark to process your data, right, you'll be loading it into something called a RDD, which is basically a resilient distributed data set. So what does that mean? Resilient just means that it's fault tolerant. So if there's any failure in the data, it's able to regenerate the data. Distributed, so same thing, right? It's distributed across multiple nodes rather than on a single node. Okay, in a cluster. Data set just means that it stores your data inside the data set. Okay, so whenever you're working with Spark, you're working with RDDs, like it's a type of data basically. So for those of you who have used Python before and you have come across this very popular library called pandas, right? You will know that pandas, typically people use pandas for data frames, right, to load your data in. So the good thing about Spark was that in Spark 2.0, they actually came up with a data frame as well. So data frame, right, is much more user-friendly compared to RDDs to work with, because you can really just think of it as like a pandas data frame, and then you can do all your analysis on the data frame. The only difference between a Spark data frame and a pandas data frame, right, is that pandas data frame is on a single standalone server, single computer, standalone mode. Whereas for a Spark data frame, it's actually distributed on multiple nodes. Okay, so that's the difference. Okay, yep. So we'll move on. So yeah, so just some misconceptions that I want to clarify on Hadoop and Spark. So typically, people think, hey, Hadoop is open source. I can just download it and use. I can just download it, install in my servers, and set up a cluster, set up the nodes, and then they'll be able to talk to each other. So it's supposed to be cheap, right? But Hadoop is not necessarily cheap. It's open source. It's free to download and install. But whenever you're thinking about big data still, right, you're thinking about huge amounts of data that is stored in your server. So to set up those servers, it may not necessarily be cheap because you still need the infrastructure to store all those data. You still need to have all those servers or virtual machines available for you to use before you can store your data. So it's not necessarily cheap, even though it is open source and free to use. Okay. Yeah. Then the next thing is a lot of people may have the misconception that Hadoop is a database because you use it to store data, right? So it's not a database, okay? It's a distributed file system. And in fact, you can kind of think of it more as a data warehouse. So a database typically, right, like a SQL database, right, typically you're just storing structured data. You're just having your transactional tables. It's a very structured data. Structured database. But in Hadoop, if you recall, one of the problems with Hadoop is that, one of the problems of big data was that data comes in a lot of, comes in different forms, right? It's a very large variety. You have images, you have videos, you have text, right? So you want to be able to store all these unstructured data inside your file system, right? So that's why Hadoop is not a database. It's more like a data warehouse because it's able to store all these kind of unstructured data as well. Okay. Next, Hadoop is only for MNCs, like big companies. A lot of people think, hey, only big companies would have all these big data that they can use, and then they can do all this big data analysis. But it's not necessarily true. Okay. So even for like maybe even for like me as a person, right? If for whatever reason I want to analyze all my sensors data, I want to analyze my user behavior. For example, I want to collect all my e-commerce logs or whatever. I collect all this data for myself, and I collect all my heartbeat, my wearables, all this kind of information. I can also do big data analysis on myself and try and understand my user behavior for whatever reason. So even like not like smaller companies, right? They can also, as long as you have the data that kind of satisfies the four V's of big data, right? You will definitely be able to do big data analysis. Okay. Yeah, so that's for Spark. That's for Hadoop. So for Spark, the next thing is some misconceptions typically is that it's always 100 times faster than Hadoop. So it's not necessarily always 100 times faster than Hadoop. It's actually on average, right? It's definitely still faster than Hadoop. It's like 3 times faster than Hadoop, but it's not always 100 times faster than Hadoop. Okay, so yeah, it's up to 100 times faster than Hadoop in terms of processing data, right? Because Hadoop uses the MapReduce algorithm, the Spark uses its own in-memory processing method, sorry. Okay. And Spark is an in-memory technology. It's not an in-memory technology. It uses in-memory to process data, but it's more of a processing framework, okay, rather than an in-memory technology. Okay. And finally, Spark is also not a database. Okay, so very important to know, Spark is not a database, it's not a data warehouse, it's not anything that stores data. Spark does not store data for you. That's why typically when you want to use Spark, right, you will pair it with Hadoop. So Hadoop will be like the big data file system, and then Spark would query the data from your Hadoop system, your HDFS, and then process that data and store the output maybe back in HDFS or store the output into whatever database or data warehouse that you have that you want to use. Okay. And of course, Spark does not necessarily have to work with Hadoop, right? You can use Spark with your CSV files. You can use Spark with your database. You can do a connection to your database. You can use Spark with other things like Kibana. So Kibana is another ELK. It's another technology solution that is used commonly for logs data, LOG. So Spark can also be paired with Kibana to try and help you process all these large amounts of log data. Okay, so yeah, Spark does not store data, it just processes your data. Okay. So yeah, so that is all I have for my slides. Let me go back to the. Okay, it's 2 o'clock. We'll do a quick 5 minute Q&A.
All right.
Yeah.
So we have our Q&A session now. Thank you, Ms. Shumin, for the sharing just now. And hope you guys understand and get more ideas. But now you can share any question on your head now, okay? So the first one we have, the third one, not the first one. We have from 1PY. Hi, you mentioned Facebook using profile data to categorize and understand their user better. What are your thoughts on what Cambridge Analytica did? Was it legal? Will this be issue that we must address in the future? Hmm.
Okay, so very good question, TY. Yeah, correct. Facebook profiling data, right? Yeah, it's kind of what Cambridge Analytica did. They actually took all the data, right? And it's like a graph. So it's really like a graph network where they have like all the profile information and they're able to see like, oh, who likes who is a Trump supporter versus who's a Hillary Clinton supporter, and they were able to try and push content to people who are like Clinton supporters to try and like change their opinion and all that kind of thing. And it was really based on the data. So there's a whole documentary I think on Netflix that kind of like talks about how this was actually not exactly the most ethical way to do things. It's kind of like going behind people's backs and trying to change the way that they think. So whenever we think about big data, right, not even big data, whenever we think about data, right, and how we actually build models based on the data and analyze this data, right, we always have something else also called AI ethics. So how we actually build the model, build all these models, use all these data against against the people. So we must always be aware whenever we're using the data. Is it something that is necessarily evil? I guess for this one, their main purpose was to kind of sway the election in Trump's favor. So that was their intention. And of course, like as employees, if let's say your company, you're doing data analysis and you feel like your company is doing something like that, and you don't feel comfortable, right? You can, if you don't feel comfortable being a whistleblower or whatever, you can also just like step out from the company and say, hey, I don't want to be a contributor to all these kind of things. And of course, yeah, whenever we do data analysis, data science even, when you are using all these data, right, building models, you must be aware how they're using it. So nowadays, right, one of the new trends of AI is actually not just AI ethics, but something else called explainable AI. Explainable AI meaning that, for example, you build a model to predict whether or not a person is going to what's the word? Whether or not a person is going to repay their bank loan or not, right? And you decide whether or not you want to grant the person the loan, right? You want to make sure your model is explainable and it doesn't have any sort of like discriminating factors inside your model. You want to be able to justify that, hey, it's because of this, and these are not discriminatory reasons that we are not granting you the loan. So I hope that answers your question a bit. Yeah, it's a bit, yeah, so if you're interested, you can go and read up more on explainable AI and AI ethics.
Oh, right. So you need to search about the explainable AI. That's the first time I heard that. Thank you, Ms. Shumin, for the sharing. And I hope she answered your question too, 1PY. All right. So the next one we have with Jugo. At present, is Hadoop and MapReduce actually used in the industries, or is it replaced by Apache Spark or any other technology completely?
Okay, so Jogo, yeah, good question. Yeah, because like Hadoop, I mean, sorry, Spark is like way faster than MapReduce, right? I think before Spark was introduced, I mean, there will definitely be people using MapReduce. So initially, when Hadoop was introduced, like in the early 2000s, right, everyone was like all into Hadoop and MapReduce, and they were finding out how to code in MapReduce and all that, right? But Apache Spark actually came on a bit later, and that's when they actually came out with the algorithm, the technology that was able to process data much faster than MapReduce. So that's why people now are kind of replacing MapReduce with Apache Spark. But if there still may be companies that maybe choose to use MapReduce for whatever reason, but Apache Spark is definitely much faster in processing the data. Any other technology wise, I'm not so sure. Okay, because for me, when I was personally using big data back when I was a AI engineer, right, I was actually using Hadoop and Spark. I was using Hadoop Spark and actually ELK. So Kibana ELK is another technology stack that you can look into, but that is more for logs data, LOG, where you use ELK, Elasticsearch, basically to store your data, and then you can use Apache Spark to query the data and analyze it. But that use case was really more for logs. So it kind of depends on your use case as well. Yeah, that's all I know so far. I'm not sure if there are any other technology that will be replacing um, Spark or MapReduce. Yeah.
All right. Thank you. And the next one is from Kosik. Is the industry today only considering the data with the four V's as a big data? I believe there's still some data existing in the cyberspace which are more complex than this, for which clustering is not possible. What is your take on this?
Wow. Okay. This is a very yeah. Okay. Thank you for your question. Yeah, this is a really complex question.
Yeah.
Okay, so let's break it down slowly. Okay, sorry, and maybe I will take this as the last question for now, and I'll move to the hands-on after this. Then I'll try to leave some time for like a few more questions. But okay, so let's break this down a bit. Is the industry today only considering the data for? No, so you don't necessarily only have to consider the four V's as your main consideration for big data, right? I mean, typically it's like a guiding principle that you use to say that, hey, I'm using big data, so I should be using Hadoop and Spark. But of course, there may be other solutions out there that you want to consider. Maybe you have a very niche use case. So, for example, cyberspace, right? If you're looking at maybe cybersecurity, it depends what kind of data you're looking at. I'm not too familiar with the cybersecurity kind of industry, but I do know that if I'm trying to draw like connection, right? Maybe if you have logs data as well, and you're trying to see like, user login, that kind of thing, which users were logging in, or maybe if you notice like some of the login patterns were like a bit off, like some user keeps trying to log in repeatedly, and that is supposed to be a flag for like a cyber breach or something. I'm just trying to draw connection. I'm not sure if this is actually the case because I really don't have much experience with the cyber industry. But yeah, if that's the case, right, you can use what's that ELK as well, Elasticsearch Kibana to help you build some sort of big data solution. Okay, and you're actually talking about clustering, right? So I don't really know what is your problem statement that you're trying to address. I'm guessing if you're doing clustering, you're trying to do some sort of anomaly detection or profiling of your data. That's why you're clustering everything into clusters, I'm guessing. Even with logs data, I guess you can do some sort of anomaly detection if you're interested. Okay, but yeah, actually, honestly, I'm not probably the best person to talk about cybersecurity. Yeah, so yeah, sorry about that. I hope I answered your question in some way.
All right. So, Ms. Shumin, you say this is the last question and you continue to your talk, is it? Or,
Yes, correct.
all
Yeah,
right. Sure.
thank you, James.
All
So,
right. Please go on. I will stop the sharing. All right.
okay, so let me just check the poll again. So most of you do have. How do I put it? Most of you okay, so looking at the polls, right, a large majority of you will consider yourself, you see yourself as a more beginner proficiency level in Python. So I'll try to go through like the more important parts of this hands-on session. Okay, so if you actually go to the Google Drive, the Google link I provided, right, you would be able to, okay, let me share my screen. You should be able to see my screen now. Okay, thanks, James. So yeah, you should be able to see my screen. So this is a Jupyter notebook for those of you who may not have seen a Jupyter notebook before. Basically, you can see that here you're using Python to open it. Okay, maybe let me go back one step. For those of you who downloaded the notebook and don't know how to open, right, you can just go into Jupyter. So you can open this. Okay, there are a few ways to open Jupyter. One way is to just search for the application in your laptop and open it, or another way is to actually go to the your terminal and then you just type in Jupyter Notebook. Okay, and then you would get this like file directory page. And what you need to do is you just need to go to your navigate to your folder where your IPYNB IPython notebook is stored, and then open this Jupyter Notebook. Okay, and you'll be able to open this. Okay, so I'm gonna try and like go through this notebook in like 10 minutes. I'll just go through like the key parts. Okay, then I mean, after this, if any of you have any questions, you can reach out to me on LinkedIn or whatever, and I'll try to answer your questions. Okay. So yeah, this is a Jupyter notebook. So for this hands-on tutorial, right, we'll be looking at PySpark on your local laptop or desktop or whatever you're using, okay? But typically when you're looking at Spark, right, you're thinking, if you recall big data, right, big data, you need to have multiple nodes. You have a whole cluster, right? A cluster has multiple nodes inside, and your data is stored on a few of those nodes, right? But we are limited by our laptops, so today we'll just be doing a very simple standalone Spark tutorial. Okay, so first, in order to actually do this, right, you will need to install these libraries. So you need to have PySpark. These are the versions that I'm using, but of course, if you want, you can install the latest version. Okay, so PySpark and Py4j. Okay, so you can, two ways to install it. One way is running it in the Jupyter Notebook like this with an exclamation mark in front. This just means that I am treating this entire statement as it's in the terminal. So I'm running this in like terminal, and you just basically pip installer. Okay. So then we move on. So if you recall just now when we talked about Spark, right? We said that Spark has something called a Spark core, which is like where all your processing is done. So that's why whenever we want to work with Spark, right, the first thing we need to do is, of course, import the library, right? So from PySpark SQL, we import a Spark session, and then we need to start this Spark session, it's kind of like your entry point API to your Spark core. So with this, right, you're able to kind of like call your entire Spark cluster, okay? And then call your entire Spark cluster, and then do whatever data processing you want to do, okay? So that's why you notice here, you always use a Spark session and you build a master node, okay? But in this case, we're just using local, okay? And you can have an app name. So app name basically helps you to keep track of your applications with your, it helps you keep track of your applications that may still be running, okay? So you can just give it whatever name you want. Okay, so when you run this and you run Spark, you'll be able to see all this information about your Spark session here. Okay, so you run this too. So let's just quickly go through reading in the data. Okay, so the first thing that we want to do is we want to read in a CSV file. So I provided a CSV file here as well, right? So you can download it and you'll be able to run this. Okay, so you can just read in this CSV file here. So you can use spark.read.csv. It's really kind of like pandas, right? You know, pandas, you import pandas as PD, then you read underscore CSV, right? So same thing, you can kind of treat it as the same thing. Okay, so you see here, you read in the CSV, put in the file path here. Okay, so this whole thing is just your file path to your file, and then it's a CSV, so comma separated, header equals to true, meaning in our CSV file we do have our headers inside. Okay, running this, and when you run print schema, okay, print schema basically helps us see for the data that we imported, what are the different data types, okay? Because one important thing whenever we do data analysis, right, is you want to make sure that your data is of the correct type. If it's supposed to be an integer, it's an integer, not a string, because that's a very common issue that we typically have. And you notice that actually, just a bit of context on this data, we're looking at stock prices. So symbol is the stock symbol, date is the date, open, high, low, close, volume. All these are integers, the opening price, the highest price of the day, lowest price of the day, the closing price, and the volume. So I would expect all these values to be float in nature, right? A double rather than a string. But right now, unfortunately, it's being read as a string. So what are the implications of this, right? if it's read as a string, if I want to do any sort of mathematical operations, it would not be done as a mathematical operation. So instead, like for example, if I want to do, let's just say 9 plus 10, right? It's supposed to be 19, right? But if I do like, if it's a string, it will give me like 910, which is totally wrong, right? Because I want to be able to do proper mathematical operations. So I will need to make sure that all these are, instead of string, it's a double, because it's a floating value point, right? So in order to do that, there are two ways that we can approach this. One way is we create a whole data schema here. Okay, so you already define your data schema. So this is typically done when you already know that your data is always going to be coming in as this format. It's always going to be having this C underscore C0 column, then symbol, then data, etc., etc. It's always going to be coming in this format. And then I'll be able to say this is an integer, this is a string, this is even a date type. Okay, this is a double, 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 etc., etc. Okay. So I can define my schema here. I can define that, hey, this column is supposed to be a string, this column is supposed to be an integer, etc., etc. Okay, and then I put it into this structure type here. Okay, and then I will read it. I'll read in the CSV file again. Actually, maybe let me increase the size in case you cannot see. Okay, and then I'll read in the CSV file again, and I'll add in a new parameter, basically saying that the schema is I want to follow this final schema that I created here. Okay. So previously I just had the separator, the header, and the file path, right? Now I have the separator, header, file path, as well as the schema. So once I run this, right, and I run print schema, I will then be able to see, oh great, symbol is a string, data is a date, open, high, low, close, all these are doubles. So it's correctly identified as a floating value point rather than a string. So if I want to do any sort of operations, I can do it easily. Okay. Another way to do it, because when you do this, it's quite troublesome, right? You need to know all your columns, and you need to know what are the data types, and you key it in. It's quite troublesome, but of course, if your data is always going to follow this type, then this is a good way to go. Another way you can actually do it is something called infer schema. Okay, so instead of schema, right, which I provide the schema, another way is I can tell Spark to try and infer the schema from my CSV file. But one issue of this, right, is you notice here, okay, so when you run this and you run print schema, right, you notice that, oh great, C_0 is an integer, which is correct, but date type, high, open, low, close is all still string. So why, right? This is because if you go into the CSV file and you look at open, high, close, low, right, there is a mixture of integers and doubles. So when there is a mix of data type, right, it will just associate the entire data type to be a string. It won't like try to like convert something to a float or convert something to an integer. It will just put the entire column as a string. So that is one thing to know. So that's why if your data is coming in as different formats, right, it may be better to just define your structure here. Okay, but if you know that your data is all integer, is all string, all float, right, you can try to infer schema. Okay, so if you want, right, you don't believe me, right, you can go back and try. You can change this stocks price final CSV file. For example, open, high, low, close, right? You can change the entire column to an integer, or you can change the entire column to a floating value point. And when you do infer schema, it will give you the correct schema rather than string. Okay, so this is something to take note of. Okay, I'll go through one more thing about PySpark data frames and Panda data frames before I go back to Q&A. And of course, you all can go back because the code is really just all here for you already. So you can just go back and run it, okay, and understand the code and how to actually interact with Spark using Python. It's pretty straightforward, especially if you have experience using pandas in Python. Okay, of course, if there are any points where you have a really dying question that you really don't know why something is happening, right, you can reach out to me on LinkedIn and I'll try to answer your question. Okay, so yeah, so let's quickly go through the pandas. here. So yeah, so as I was mentioning, right, you can also very nicely convert a PySpark data frame to Pandas data frame because essentially they're both like kind of like data frames, okay? But one thing to note, right, is that it should only be done on small subsets of data, especially if you're running it on your laptop. Okay, because pandas, right, is built for smaller data sets. Pandas, in its nature, is built for like a standalone mode. It's not typically used in like a cluster mode where it's distributed on multiple nodes. So if you run it on a large data set, right, it may create a memory error and your entire Jupyter will just hang, and then you need to close the entire notebook and restart it again. Okay, take note, just run it on smaller data frames, smaller data sets if you are trying to convert it. Okay, but very simply, right, if you want to convert your data into a pandas data frame, you can just do a dot to pandas, okay, and immediately you will see you have a pandas data frame here already. Okay, and you can do any sort, once it's in a pandas data frame, you can really do any sort of pandas panda operations on your data frame. Okay, so yeah, I will stop with the hands-on for today. You all can go back and really look through the code. It's pretty straightforward, okay? But of course, if you have any dying questions that you can't figure out, you can reach out to me. Okay, so we'll go back to the hands-on. Oh, sorry, to the Q&A.
All right, thank you, Ms. Shumin. I hope you guys follow Ms. Shumin doing. And now we have the Q&A section from first question from Fernando. Aside from Hadoop and Spark, what other tools are used for big data? Tableau, how to read this? I'm not sure. Also used for big data. Thank you.
Yeah, okay. Good question, Fernando. Yeah, so besides Hadoop and Spark, right? So Hadoop and Spark, typically Hadoop is like your data, like you kind of like store your data in Hadoop, in a Hadoop file system, and then Spark, you use it to process your data. Of course, once all this is done, right, you can then from Spark, your processing engine, right, you can store your results, your processed data into Hadoop. Or if you want, right, you can also take the processed data and store it in another database, or you can store it as a CSV file, or you can store it in another in if let's say you have an AWS, if you have an AWS account and you're gonna store it in the cloud, all that kind of thing, you can store it anywhere. And then of course after that, right, because all this is data, right, and of course you may have other stakeholders who want to try and understand your analysis from your data, right, and of course bring up data visualization is definitely a very good way to help non-technical stakeholders better visualize and see the data, right? So Tableau is definitely a good way to actually visualize your data. But in terms of big data connecting directly to Tableau, I'm not sure if Tableau has the capabilities to work with big data. So unfortunately, I mean, okay, what I do know is ELK, again, the same example that I mentioned just now. So if you're interested, go and Google ELK. It's called Elasticsearch Stack. Basically, they have an equivalent of Tableau called Kibana. So Kibana is also another data visualization tool that can be used to visualize like huge amounts of data as well. Okay, so for Tableau, I'm not sure if it will start to get laggy, if it will start to hang if you're visualizing like big data, like huge, like not just gigabytes, but like petabytes, terabytes of data. I'm not sure if it will hang. So, but of course, when you process your big data, and for example, you bring it down to like aggregations, right? When you aggregate your data and you have all your different metrics that you want to show, of course, you can definitely visualize that using Tableau. But in terms of like your pre-processed data, right? Your huge big data, I'm not sure if you would want to visualize that. Yeah, but of course it depends on your use case lah. Yeah.
All right.
I hope that answers your question.
All right. Thank you. So far, the next question also from Fernando, but because time is running, so I think I will just skip one of your question. If we still have time, I will come back to you. All right. So the next one is from Kosik. Open this file using Jupyter Notebook found this following: Apex Spark Core, Extensible API, Python, PySpark, R, Scala, Java. Are these languages that the Spark support?
Yes. So Spark actually supports, besides Python, right? So using PySpark, it also supports R, Scala, Java. In fact, if you want to use Spark and you really want to optimize your code in terms of runtime, right? Scala would actually be the most ideal language to work with, because Scala is a lot more optimized in terms of like the back end, behind the scenes, what's happening. Scala is a lot more efficient in running your codes compared to Python. So even if you have a Python PySpark code and a Scala code, right, they are exactly both like the most efficient you can code it, right? Scala is better lah. But because Python is a more kind of like universal language, so that's why I chose to do the notebook in Python today. And Scala is a bit more complex to learn. But of course, if you have to pick between Python and Scala to learn as a new language and you are using Spark, I would definitely recommend Scala. Yeah, I hope that answers your question.
All right, thank you. So next one we have Lee. For data visualization, what tool can you recommend?
Okay, so good question. For data visualization, right? There are many different tools. It kind of depends on your use case and depends on if you're a student, right? I know a lot of the data visualization tools like Tableau and Click have education licenses that you can use, and then you can immediately try and get hands-on experience and learn how to use them. If not, there are really a lot of different tools. Okay, so what would I recommend, right? In the industry, a lot of people are the big players are definitely Tableau and Click lah. ELK, I keep going back to ELK. Kibana is another up and coming tool that is also used quite a lot. And in fact, I think the charts are quite decent, are quite pretty to look at. But yeah, in terms of the big players, I would say Tableau, Click, Kibana. Some of the other ones, if you're interested, you can look into Seasons. Power BI, another up and coming tool by Microsoft as well, gaining quite a lot of traction. Yeah, those are the ones I can think of at the top of my head. I know that there are some legacy systems that use some older data visualization tools, but I'm not so familiar in that region. Yeah. So yeah, I hope that answers your question.
All right. Okay, I hope you get your answer, Lee. And next one, Ellen Tan. Hi, there are a lot of tools available such as Hadoop, Apache Kafka, Apex Spark, streaming. How do I decide which tool is better for use case that focus on data processing and streaming?
Okay. Hi, Ellen. Oh, this is a very good question. So I would say this depends. Everything depends. Okay, so it depends on your role in the industry that you are trying to play. So are you a data engineer? Are you playing a data engineer role, or are you going to be playing like a more infrastructure? You're more concerned about the entire infrastructure of the setup of your solution, so more like a solution architect role, or if you're even maybe a data science. Okay, so if I'm assuming you're probably going to be coming from a data engineering role. So data engineering, right, I would say that if you want to focus on data processing and streaming, right, I will focus if you are, I mean, all those tools that you mentioned actually are part of the entire solution that you will need to build to do data processing and streaming, because you will need Hadoop to store it, you will need Kafka to let you know when more data is coming in, and Spark will be helping you process your data as it comes in. So you kind of need to know the entire tech stack lah. But yeah, you will need to know everything, especially if you are going to be a data engineer that is focusing on this entire solution. I would say maybe though the key thing to start learning first maybe is Spark, okay? Because in Spark, it's really when you do your transformation on your data. And if you don't have any prior programming background, that may be one of the harder ones to pick up. So maybe picking up Spark would be good. And of course, when you process your data, right, using Spark, that can be changed easily. If you don't want to use Spark one day, you want to use MapReduce, or if you want to use your own another like another specialized application, right? You can also do so. But really picking up the programming language is will be the best to focus on for now. Yeah, I hope that answers your question.
Okay, so thank you. So because the time is running out, so maybe I just choose one last questions. All right. Who did not get their answers, so please connect with Miss Shumin through her LinkedIn or is it okay LinkedIn, right?
Yeah, definitely,
Yeah, okay.
definitely.
So
Yeah.
maybe Miss Shumin, you also can share out your LinkedIn link
Okay.
Yeah. Okay. So I will pick one question. Okay. So all right. So maybe Shin. Is there a library source for the code to take in stock price in real time?
Hi Sheen. Oh yeah, good question. So did I not put that in my? Oh no, it's not like this. Okay. There are actually a lot of different libraries. I'm assuming Python, right? So there is actually a very good. There's actually a free API that you can use called Y Finance, if I'm not wrong. Like really letter Y, Yahoo, then Finance, Finance. It's actually by Yahoo Finance. So what they did was they actually have a free API where you can query stocks. Um, it's an API, so I mean, if you want it in real time, you can do some sort of streaming whereby you query your API every few seconds. But because it's free, I'm not sure. They have a paid version also, so I'm not sure how many API calls you can do per minute or per minute. But you can use that Y Finance library to get stock prices and and you can define your time period that you want your stock prices for, whether it's yesterday or today or last week or whatever.
Oh,
Okay. Yeah.
all right. Thank you. So Mishumi will share out her LinkedIn account
Yeah.
in
I
the
will
chat.
just share it in the chat.
You already share in the chat. Okay, let
Oh
me.
yeah, I'll just share it now. Yeah, I just shared it in the chat.
All right, so I got it. I see
Hmm.
the chat. So everybody, please, if you have any else questions you want to get answer from Mishumi, and you want to know more about Smartcademy or relevant things, so please connect to Mishumi and ask. All right, and for today, our first workshop is end, and our next workshop will be started at 3 p.m. Let's have a 30-minute break from now. I will see you after 30 minutes. Okay.
Yeah.
Thank you, everyone. Bye bye.
Thank you. Thank you, everyone. Thank you, James.
Thank you, Jimmy.